Hello, everybody. My name is Bart Verheyen, and I work at IMDC. IMDC is an international engineering and consultancy company in the field of natural waters. And we are about 100 employees and based in Antwerp, Belgium. And I will present to you our model approach for assessing and forecasting bathing water quality along the Flemish coast. And yeah, like in other European countries, Belgium has to comply with the bathing water directive. And that means that we have to monitor and assess the bathing water for at least 2 parameters of fecal indicated bacteria, which are E. coli and intestinal enterococci. We have to inform the public about the bathing water quality and, if possible, forecast short-lived events. And at present, the monitoring is based on sampling on regular intervals. Somebody of the Flemish Environmental Agency takes samples, which are then cultivated and grown to calculate concentrations. It takes about 24 hours to get the values, quite long. And if there is a bad quality, if there's a threshold exceedance, then the healthcare department can issue an advice to close the beach, which has happened before. But due to the long time lag to assess the quality, it's often only for really strong events or bad events that the beaches are closed. And so both the environmental agency and the healthcare department are interested in more efficient methods and as a forecasting tool. To situate the project, we're looking at the Flemish coast in Belgium. We were supposed to be in Brussels now, but everybody's at home, I think. I'm in Antwerp now. And the system is developed then for the environmental agency and the healthcare department. So in general, the water quality is good in Belgium, but in summer months it can go wrong sometimes. And the reasoning is, so what is the reason for bad water quality? It's that we have a densely populated coastline. And especially in summer, when there are thunderstorms, strong rain events, the sewage system cannot handle everything, and there is an overflow in the harbors. These are the 3 harbors where there is overflow events, and that from where there can the pollution can spread towards the beaches. For instance, in Blankenberge, this is an example. The system, the city system, the sewage system discharges through a pump system here in the port. Most of the overflows are like that, where there is a direct link between the sewage system and the port environment. Except in the biggest port in Ostend, here in the middle, there is one system where there is first a discharge from the city in like a kind of reservoir system. It's shown here, and then there is a link to the port there with pumps, but also gravitational discharge. So the whole system has been studied before. There goes back to 2010 when the first numerical models have been set up to study the dispersion of the fecal bacteria. And then along the way, more ports have been added. There has been an extensive measurement campaign in Ostend to be able to validate the models. There has been trend analysis to compare exceedances or values with environmental parameters such as the rainfall, wind, waves, sunshine, which was actually quite a difficult exercise since there is limited concentration data of the fecal bacteria to compare with. And then one of the important aspects is that often these rainfall events occur during the late afternoon or night, when there is the thunderstorm, and there is a strong influence of the decay during night and day. impact of the sunshine. So also a decay campaign with in situ testing has been organized. And then finally, we're in the situation of setting up the operational forecasting system where we're in now. So the approach, it's that we've set up a Synapse system. And Synapse, it's a modular system that combines all kinds of different modules, different models, tools, communication with websites, so that we can continue based on the available knowledge and models that are there. What does it mean? It's there is a front end for visualization interaction. There is the engine behind it, the calculation models for the forecasting and the processing, and then data storage where all data is kept. If you go a bit deeper into it, we've got these different models of Synapse. There is the user interface. There are the discharges of the pumps at the overflow locations. This data is collected and used to start up model scenarios. Wind data is collected to steer also the model simulations. And if you go here, there is the actual model that is run. There is a threshold analysis for the water quality criteria. There is a possibility of measurements to upload them, to compare, and then there is a communication part to publish the results. And on the right, there is a typical flow chart of action. So there is, let's say, a rain event, and one of the pumps becomes active. Then that signal is sent to the system. An operator gets a warning. An automatic forecast is started up that simulates dispersion of the bacteria along the coast. Alternatively, a user can provide its own inputs and start it. After the simulation, there's a threshold analysis. If there's an exceedance, an email is sent, the operator is warned. Then this part, the operator himself has to verify whether he agrees or not, whether it's false positive or not. And then only then the results will be released to both the public website or the relevant authorities. And what is also interesting to say here is that we have selected in this case to incorporate a process-based model to forecast the dispersion and not a true-false analysis because basically there is not enough data on the exceedances or non-exceedances based on the samples of the fecal bacteria concentrations to, for instance, make a good data-driven approach. And also this way, there is the simulation of both hydrodynamics, so the tidal flow and variation in concentrations that allows for the operators to assess whether it's a relevant impact or not. And also helps to schedule monitoring when it's the best moment to take a sample. And finally, it's also something that is more visual for, let's say, public, to discuss with the local coastal towns, and it's understandable when introducing the system. So now I'll show a bit more on the model setup, let's say the engine behind it. So there are two models. There's a model train that is running. And there is the red one generates hydrodynamic conditions, so tides and flow for the black one. And the black one, it's a near field model that's a 3D model where the actual dispersion of bacteria is calculated. It's 10 layers and it's about 1 hour to calculate 5 days. So there's a 2-day hindcast and a 3-day forecast. It's the bathymetry. So the sources of the model are generated in the ports. So when a signal comes in of a pump action, so for instance, for that overflow in Blankenberge, those pumps are monitored by the responsible for drinking water and sewage system, which is called Aquafin. When that call comes in, they push it to our system so that we know the start and end date of a pump. action, and we also have some key characteristics like discharge and capacity of that sewage system and concentrations. And with that, time series are generated for the model. So in this case, for instance, there is a first, in blue, you can see the discharges, several ponds become active. And then in green and black is the concentrations. So there is a first flush of bacteria. When the waste capacity has gone out, there is a freshwater discharge. In case of the more complex case in Ostend, I'm not going to go in too much detail it, but there is like an intermediate box model that translates the pump actions into the reservoir system and then translate it to discharges and concentrations. These are the pump actions. And then there's a translation into discharges and concentrations into the port. So to have like a good forecast of the bacteria, well, it starts already with a good representation of the hydrodynamics, so the flow that control the dispersion. So we calibrated the tides and the flow condition. In blue, you can see model results, in red, measurements. So we're quite happy with the flow distribution of the model. Also, the water quality has been calibrated based on that extensive campaign in Ostend. And there the focus was mainly on representing the patterns and the accidents or not on the beach location. Here you can see two results. In red crosses are measurements. And for instance, on the right, you can see at that reservoir in Ostend, how there are certain peaks popping up when there is a discharge event. And with the parameter model, the box model, we are able to represent those peaks with certain settings of the parameters. And then on the beach itself, you can see in full line model results. So there is like the concentration pops up when the bacterial plume passes by. And that occurs a couple of times. And then based on the measurements, we can see there are two times bad quality, while the third time it remains under the threshold. And based on that, we were able to calibrate the decay rates and find, in this case, we used the blue full line as a representative approach. This shows the dispersion in the port. I'm not going to show the entire movie because that will take too long. But there you can see how now red is the bacterial plume, but the blood level is going up, so it remains in the port. And when the water level goes down, there is the emptying of the port, and the plume starts to be released and is transported with the tide along the coast. And so at that moment, we can, at that point, there would be an exceedance forecasted. So there was some background on, let's say, the engine, the model setup between the Synapse system. I'll shortly show some of the other features of the system. So it's a web-based tool, and this is the, let's say, the home page of the tool, where you can see there is an observation tab where all the wind data can be seen that is downloaded. Also measurement that can be uploaded can be found there. There is the overflow tab, that is the database where all the pump discharges are collected that we've seen before. There is the simulations tab that where all the forecasts can be made visible, and a map tab to check the results. This shows the simulations where you have the start date, end date, whether there was a threshold exceedance or not, success, gives some, here you can find some information, check the map, and then this one allows the operator to publish the results, or if he thinks it's not valid, not to publish it. So he can, that's a manual action. If we check, for instance, the info tab on a run, it's been implemented such a way that you can directly see the key data on overflow. It's in Dutch, since it's used in Flemish. And then there is like a matrix showing for all the stations along the coast at what moments there is an acceptable or an unacceptable status of the water quality. Finally, there is the map view, where, for instance, in this case for Blankenberge, you can visualize the results. This shows, in the time series, shows the discharge at the pump. So when there was introduction in the system, then you can see the next tide, when water was released from the port, the operator can inspect the exceedance here of the E. coli above the threshold. It's clear that this is an exceedance, but you can then see the times and so on, which allows him to schedule maybe a monitoring. To finalize, we're still in one of the steps for the tool. We've run it this summer in operational modus, but there has been also done some measurements. So after this summer season, we're going to check further on false positive, true positives, and exceedances, and so on. The next step is then to make public awareness of the tool and to show that it's been that we'll also publish on the water quality website for Flanders, and to present it to the coastal towns, to the lifeguards that will be responsible for the closing of the beaches, and to the community. And yeah, we're open for possible expansions of the model, further improvements. So with that, I will conclude the approach we did on that forecasting system. And thank you for your attention. And I'm open if there is time for any questions, or later on if there are any questions.